everyone. Today we're going to explore something very important in mathematics. But don't worry, it's not just about numbers. We'll be talking about processions, which are clear and simple statements that can either be true or false. You might be wondering why are propositions important? Well, they are actually the building blocks of logical thinking in math. Whenever we solve problems, make conclusions, or prove something, we are using propositions even if we don't realize it. In this role play, we will learn what propositions are how to tell if they are true or false, and what different kinds there are, like simple, biconditional statements. We'll show examples and explain how each one works. By the end, we hope you'll see that math isn't just about solving problems, it's about thinking clearly, logical, and truthfully. So let's begin our journey into the world of propositions and action.
Welcome everyone. Today we will dive into the fascinating world of propositions in mathematics. Let's start with a simple definition.
A preposition is a statement that can either be true or false. It's all about precision. It must be clear enough to have a definite true value.
For example, 3 plus 2 equals 5 is a proposition because it's true. But sometimes, like x is greater than y isn't a proposition unless you know the value of x and y.
And propositions are the foundation of logical reasoning in mathematics. So let's talk about the types and examples.
Alright, the first type of simple proposition is just one statement with a clear true value.
Like 7 is a prime number which is true.
Or 9 is even number false. Next is the compound proposition. This combines two or more simple propositions using logical operators like and, or, and not. For example, 3 plus 2 equals 5 and 9 is an even number. The first part is true, but the second is false, since both parts must be true in a compound preposition with and, the overall statement is false.
Now for conditional proposition, these have an if-then structure. For instance, if x is a greater than 2, then x is a greater than 4. This is only true if x really is greater than 2.
Negation flips the truth value of a proposition. For example, it is not true that 5 less than 3. That's true because 5 less than 3 is false, and negating it makes it true. Let's talk by conditional propositions. These use if and only if, like a number is divisible by 2 if and only if it is even. Both directions must hold true.
But what if we have 3 is prime or 10 is prime? Only one part needs to be true for the whole compound proposition to be true.
Good example, Linya. It shows how logical operations affect true values. Let's test ourselves. Which of these is proposition? The sum of 2 and 3 is 5. It's sunny outside. X plus y equals 10.
Only the first one is a clear proposition, which is true. The second example, it depends on weather. And the third needs specific values for x and y.
Propositions aren't just about truth. They're about building logical foundations. Without them, we could create proof or solve problems systematically.
And understanding types of proposition help us analyze complex ideas with clarity.
So whether you are solving an equation or proving a theory of propositions, keep us grounded.
Exactly, they're like the building blocks of mathematics.
And they're everywhere. Conditional statements, negations, and compound ones, all shaping the way we think in math and beyond.
So remember, math isn't just number, it's about logic, structure, and trust.
Propositions are more than just statements. They are the building blocks of logic that guides us
to make sense of complex ideas in mathematics and beyond. By understanding their truth and values, we gain the tools to approach problems systematically. So math isn't just about solving equations, it's about discovering the truth through logic.